Today what we're going to look at is what's referred to as the general multiplication rule. And then also we're going to look at tree diagrams. And the tree diagrams you've probably done maybe a little bit with in the past. But the general multiplication rule, this is going to kind of expand upon our conditional probabilities that we've looked at. Here's a situation where we might use that general multiplication rule. This says that about 55% of high school students are going to participate on a school athletic team at some level. Roughly 5% of those athletes go on to play for a college team in the NCAA. We want to know what percentage of high school athletes play a sport in high school and they go on to play on an NCAA team. So we talked about or the other day. This is a situation where both of the things have to happen. That we want to know the percentage of high school athletes that played a sport in high school and then they go on to play that sport in college or on an NCAA team. Well, like I said, in order to answer a question like this, we're going to have to use what's referred to as the multiplication rule. So here's the general multiplication rule. If I want to find the probability of event A and event B happening, what I'm going to do is I'm going to take the probability of event A happening and I'm going to multiply that by the probability that event B happens, given that A has already happened. So for this situation here, we want to know what's the probability that they played in a high school sport and they played on the NCAA team. So to answer that, I'm going to first of all figure out, well, what's the probability that they played in a high school sport? Well, they said 55% played in a high school sport. So that's 0.555, not 555, 0.55. I'm going to multiply that then by the probability that they played on an NCAA team, given that they played a high school sport. Well, that was the other piece of information we had here. They said that roughly 5% of these athletes go on to play for a college team. So the percentage here, or the decimal here, would be 0.05. So to find my probability, I'm going to multiply these two things together. And when I multiply 0.55 times 0.05, I get 0.0275. Or in other words, 2.75% chance that a high school athlete goes on and plays for an NCAA team. That's an example of the general multiplication rule. Let's look at another example. This one says that the Internet and American Life Project found that 93% of teenagers ages 12 to 17 use the Internet, and that 55% of online teens have posted a profile on social networking site. We want to find the probability that a randomly selected teen uses the Internet and has posted a profile. So we want the probability that they use the Internet and they have a profile. Now this data is probably a little bit out of date because I'm guessing that percentage would be higher now, but what we're going to do is we're going to figure out, okay, first of all, what's the probability that they have Internet, and we're going to multiply that by the probability that they have a profile, given that they have the Internet. So let's start with the percentage that have the Internet or use the Internet. Well, according to this, it was 93%. Then I look at, well, what's the percentage that had a profile given that they had the Internet? Well, that was the other part, the 55%. In And so when I multiply those two together, I get this, 0.5115, or roughly 51.15%. So the general multiplication rule, it looks fancy, but really we're going to just take those two values and end up multiplying those two values together. Well, that multiplication rule really ties into the last part here of tree diagrams. So what's a tree diagram? Well, a tree diagram shows the sample space. That's important. Remember, sample space was when we're looking at all the different possibilities we could have for a situation. But a tree diagram shows the sample space of a chance process involving multiple stages. The probability of each outcome is shown on the corresponding branch of the tree. And I'll show you a tree diagram here in a second. All the probabilities after the first stage are conditional probabilities. We talked about conditional probabilities in the last section. So the conditional probabilities basically are based on what happened before them. All right, so here's the situation. And the tree diagram that would go with it. So our situation is Shannon hits the snooze button on her alarm on 60% of the school days. Some of you may relate to that one. If she hits the snooze, there's a 70% probability that she will make it to her first class on time. So 70% of the time, even though she hits snooze, she still makes it to class on time. If she does not hit the snooze and gets up right away, now there's a 90% chance that she makes it to class on time. So like I said, here's an example of a tree diagram for this situation. Notice the tree diagram starts with the two options that can happen when she first wakes up. She could hit the snooze, or she can not hit the snooze. They said 60% of the time she hits the snooze. So that's why this branch has 0.60. The other 40% of the time she wouldn't hit the snooze. That's why this branch has the 0.40. After she makes the first decision, whether she makes it on time or not is based on what decision she made initially. And that's why it's considered a conditional probability. First of all, what's the probability that she makes it on time, given that she hits the snooze? So from that option of hitting the snooze, they said 70% of the time she makes it on time. So that's why that's 0.70, which means the other 30% she's late. Versus down here, if she doesn't hit the snooze, 90% of the time she makes it on time. The other 10% she's still late. That's an example of a tree diagram. It has all the possibilities that can happen. She could hit the snooze, and then she could be on time. She could hit the snooze and not be on time. She could not hit the snooze and be on time. Or she could not hit the snooze and not be on time. So those are really the options that could happen here each day when she wakes up. All right, well, let's use this tree diagram to find some probabilities. So here's that same tree diagram. And we're asked, first of all, what's the probability that Shannon hits the snooze button and is late for class on a randomly selected day? Well, what I like to do is I like to just follow the branches for the situation. So the first thing they said was that she hits the snooze button. So she hits the snooze button, we'll be following this branch. Then it says that she's late for class on that day. So that would be following this branch because she ended up being late. Well, this is the general multiplication rule, because now all I need to do is take that first probability of 0.60 and multiply it by the second probability of 0.30. Because remember, everything after the first situation was really just a conditional probability. And when I multiply those two together, I get 0.18, or 18%. There's an 18% chance that this would happen. She hits the snooze and she ends up being late. All right, what about this next one? This next one says, if Shannon was late for school on a random day, what's the probability that she hit the snooze button? Well, think about what this is saying. This is saying, what's the probability that Shannon hit the snooze, given that she was late? So we already know that she was late. We've got to figure out, okay, what's the probability that she actually hit the snooze? Well, this is going back to a formula we talked about in the last section. In the last section, we said, what's the probability, or when we have a conditional probability, we're going to look at the probability of doing both divided by the probability of the given fact. So let's start with the first one, the probability of hitting snooze and being late. Well, that's what we just answered here. We just said that the probability she hits the snooze and is late is going to be 0.18. We're going to divide that by the probability that she was late. Well, her being late could have happened in one of two ways. It could have been the way that we just talked about, where she hit the snooze and then she was late. That was the probability of 0.18. But also, she could have gotten up right away and still ended up being late. Well, let's see what that probability is. Well, if I took the first branch of 0.4 times the second branch of 0.1, I end up with 0.04. So there's two different ways that she could have been late. The 0.18 and the 0.04. So I'm going to put those together. And so the probability for being late would be 0.22. That's what I'm going to divide by. So backing up, I figured out what's the probability of both of these things happening, the snooze and late. And then I divided it by just the given fact. And so when we actually divide those two things, 0.18 divided by 0.22, my probability is 0.818 that this would happen. So conditional probabilities, you can use our formula to help us out. All right, let's put it all together here. So last example. This example says, recently the Harris Interactive reported that 20% of millennials, and they said millennials would be 18 to 36-year-olds, 25% of Gen Xers, the 37 to 48-year-olds, 21% of baby boomers, which would be 49 to 67, and 17% of maturers, which they would call the 68 and older crowd. They said that those different groups read more ebooks than they did paper books. According to that Census Bureau, it has all these different percentages of people they looked at. So 34% of those 18 and over are millennials, 22% were Gen Xers, 30% were baby boomers, 14% were maturers. All right, so based on those results, we're going to first of all just try to make a tree diagram to model this process. Well, as we make the tree diagram, the first thing we got to think about is, all right, well, who did they talk to? Well, they talked to different age groups. And in this case, there were 4 different age groups. Now, I'm going to abbreviate a little bit so I can fit all this on here. But basically, I've got 4 age groups. I've got the millennials. I've got the Gen Xers. I've got the baby boomers. And I've got the matures. That would be my first step, just listing out the 4 groups of people they talk to. Now, each of those branches, because they're not equally likely, it wasn't the same percentage for all 4, we need to write down what percent fit into those groups. Well, they said that 34% of them were millennials. So I'm going to put 0.34 on this branch. They said 22% were Gen Xers. 30% were baby boomers. And finally, 14% were matures. So don't forget, you always want to label the probabilities on each branch. All right, well, the second thing is, now that we remember which category they were in, we asked them basically, do they read more ebooks or more paper books? So for each one of these, there was 2 things. It would have been ebooks or paper books. And that would be true no matter what group we were looking at. So those would be the branches off of each of the different age groups. Well, according to their results, they said 20% of the millennials read more ebooks. So I'm going to put 0.20 here for ebooks, which means the other 80% read more paper books. Gen Xers, well, they said 25% did ebooks, which leaves me 75% for paper. The baby boomers, they said 21% were ebooks. So that leaves 79 for paper. And finally, for matures, it was 17% for ebooks and 83 then would be left over for paper. So that would be our tree diagram. That's the entire sample space because it has all the options and it has all the probabilities for each of those options. Well, here's the question we're going to try to answer based on this tree diagram. They want to know what's the probability that a randomly chosen person reads more ebooks than they do paper books. So if I'm focusing just on the ones that read more ebooks, and we're not concerned with what age group they were in, I've got to look at each age group individually and then put them all together to find the total. So if I start out with the millennials, well, the millennials had 0.34, and then they had 0.20. So I'm going to multiply 0.34 times 0.20, and I'm going to see what I get. So if I take 0.34 times 0.20, I get 0.068. All right, now I move on to the Gen Xers. The Gen Xers is 0.22 and then 0.25. So I multiply those together. So that's 0.055. Then I look at the baby boomers. Well, the baby boomers would be 0.30 and 0.21. So that's 0.063. And then lastly, we have the matures. So that was 0.14 and 0.17. So that is 0.0238. So those are all the different ways that I could look at who read more ebooks. So to answer this question, I'm going to put all those together. So I'm going to add up all those different values. So I'm going to add up the 0.068 and 0.055, 0.063, and the 0.0238. And so when I add all those together, I end up with 0.2098. So the probability that I chose someone randomly and they read more ebooks than they did paperback books would be roughly 20.98%. So tree diagrams, again, a nice way to organize things as we start looking at different sample spaces. And then once we have that organized, it's a nice way to answer different probability questions.